Hello. In this video we'll be talking about physical and logical secure network design. We're talking about network architecture, and overall philosophy, and on designing a secure network. So we got a anonymous Dumbo octopus. Anyway, someone's looking at the notes. That's fine. All right. So practical paralysis. So let's get started. So what's the difference between architecture, framework, and design? What's the difference between architecture and framework? So network design is just a small part of the whole infrastructure of architecture, the network secure architecture of a company. Okay, network design just has to do with is just how the network is interconnected, right? At layer 1, layer 2, layer 3, logically, physically, right? However, an architecture deals with the company as a whole, right? It's a large picture of an enterprise and its information systems. An architecture contains network design, but also has design principles, deploys methodologies, business and information systems, and more. Architecture could deal like how we're gonna the system we have in place to check and double check applications for deployment for security problems, right? Or potential opening us up to vulnerabilities, or how are we going to make our own applications? What's our process for testing and hardening our applications that we designed in-house? All that's part of the architecture. All right, and it's going to involve obviously the business processes of whatever enterprise you're working for, be it nonprofit, government, and of course business. Every business is going to be different, right? There are lots of theories out there on how to build, architecture, and how to build it out, and how to design an architecture for a company. But every company is going to be different. The people are going to be different. The business processes are going to be different, and so every architecture needs to be different. And especially when you look at type of businesses like healthcare versus government versus education versus financial. Versus technological companies, right? All these companies have a very different business processes, and because of that, the network architecture is going to have to be dramatically different. So that being said, if that's an architecture, what's a framework? Well, framework essentially is a list of best practices, right? A good way to look at a framework is, the term it's based off of, right? If we have a framework for a house, for example, right? If we sit there and say, here's my switch stack drawing, which is awful. Here we go. New. Great. So if I give you architectural drawings of how to build a house, just overall, right? Support beams, this is, it's going to have this type of roof. It's going to be, structured this kind of way. I'm not telling you how many rooms to put in there, where the window should be, where the door should be. What I'm doing is saying, listen, here's the framework. This is how we're going to frame out the house. What you put inside is going to be up to you and yours, right? Same thing with a framework when it deals with networks, right? If we have a framework, what we're saying is, listen, these are the bones, right? This is the structure, and then you need to customize this to your particular deployment. So it's essentially a list of best practices and suggestions from previous experiences to help you form your own architecture. So the important concept here when we look at secure network architecture is, again, zones, right? We talked about this already a couple times, but it's an important point. Every time we have a firewall, right, and we're coming off that firewall, actually, why don't I grab, that's the VPN double. Let's do this, firewall double. So let's grab this, okay? These are zones, right? And by having our zones split off into different areas with different security ratings, right, we are isolating, not isolating that traffic, but we are segmenting, right, that data. we're putting it into different network zones. This buys us a couple things. First of all, if I was to look at this very simple drawing and say what's the most likely, scenario in which this network would be compromised, well, maybe I'm just a pessimist, but I think it's going to be the users. Okay, I think it's more likely than not that one of these users will go out and download some malware, and so what we're doing by having the users off on this network zone is we're essentially putting another layer of defense. Another way to look at this is because we have the outside world, right? Outside. And then we're going to form the first perimeter. Ooh, geez, that's a terrible circle. I was trying to avoid drawing over users, but I think in order to put a circle, we're going to have our first perimeter of users, right? Because they're the lower security rating, okay? And again, they're the ones that are most likely to be compromised. But because we've set up a separate network zone of a DMZ, yeah, they might have more permissions to get to this web server than the outside world, but still, there's going to be less vulnerabilities than if you're on that same exact network, right? So it's a form of again segmenting that data, and by segmenting that data, what we're doing is we're creating we're creating layers of defense, right? The old phrase in football, right? Bend, don't break. I tend to look at things like perimeters because that's just a little bit of my background. Is when you stop moving, you form a circle, and when you set up a base, you form a circle and make sure that everything behind you is good guys and everything in front of you is bad guys, right? So that's where I'm coming in with these perimeters, right? But that's what these zones essentially do, right? If someone's going to come in, now they can make a direct strike right to the inside. That's possible. Well, it's not going to be very difficult. If I don't punch any holes to the inside, that's going to be very difficult from the outside, right? But they might be able to go right into the DMZ. So let me back that up and go right into the DMZ, right? We have our web server here, so if there's a vulnerability in our web server and they're able to attack our web server, sure, they can break into the DMZ. And from that DMZ web server, there's probably an SQL, this is SQL database server, so there's probably an SQL hole punched through this firewall to allow the web server to do some SQL queries and look up information here. And so maybe we can piggyback on that. But what I'm doing is I'm creating defense in layers, right? The old football adage, bend, don't break, right? By segmenting my data and creating these network zones, what I'm doing is, I'm giving up, a first down here, a first down here, a first down here. But as we go deeper into my own area of the zone, my defense gets to compress shorter and shorter and have less area to defend, right? And so the defense can kind of get tougher and tougher and tougher, right? So that's the bend, don't break philosophy. All right. All right, so zones, perimeters, and layers. So how do we protect data as it's transmitted? So again, defense in general, it's too much to comprehend. You can't think of, you can't have a good answer for every possible attack because you can't think of every possible attack. So one way we can help us figure out what we're doing is we can start classifying information, right? Is we can well, in this case, classifying information, right? So we're gonna have data in two flavors. We have data in flight and data in transit, right? So the book uses data in flight. I'm not in love with that term. I prefer the term data in transit, but whatever. So it's going to be used interchangeably here. But so I put data in flight on the slide here. So how do we protect data that's transmitted from one node to the next? Well, we have to understand what we control and what we don't control, right? If that data is being transmitted from one of our users' workstations out here, and it's going through the cloud, we don't control this cloud, right? That's the internet. If it's within our company, well, that's the intranet. We can control that, right? And one way we can do it, if we do control it, is check our wiring, right? We make sure our wiring is protected. We use protected distribution system. We have good physical security, so that we just don't let anyone into the building. We make sure the wiring, if it is outside, is locked down with metal conduits. That's part of the protected distribution system, right? It's something that's hard to get to, not just cheap plastic to cut through. Because remember, all it really takes to get to see all the information flowing right between two nodes is simply to cut that wire and plug in either end, right, into a hub, a little portable hub, and then you can see all that data, right? So protecting that wiring is an important thing, and that to help protect the data in transit, right? So what you protect, what you can protect, what you can't protect. If I can't control it, what I can use is some encryption. While the data is in transit, I can use encryption, right? And so going back to our drawing here, if I have a laptop here and they're coming in and they're doing some work on my network, it'd be really good idea for me to have a VPN solution, right? And they can connect up to a VPN client running on our firewall, or I can have a concentrator in the DMZ, whatever it takes, right? But what we're going to do is we're going to encrypt that data on that WAN connection, because we can't control it. If we can't control it, we should encrypt it to try to hide it, right? So we can use encryption, VPN, use good policies. Remember, if we have this person accessing information on our company, yeah, we've protected it in flight, but when it's in their computer, we need to have good policies to make sure that they're not running malware, or they're not creating a backdoor into our network, or that type of thing. So policies are also part of it, right? And again, we can do integrity and verification. So this is more DLP, data loss prevention. We can make sure that any data that's leaving the SQL server, for example, we can put a DLP service on this server, right? There could be a DLP service running that anytime data is accessed on this SQL server, it doesn't go anywhere but the web server or to our users, our user network, right? And if it does come into the VPN, right, to make a log of it to figure out who's accessing this data and should they be accessing it, right? And that's what we're going to talk about when we talk about maintenance, is looking at your logs and verifying, right? So in other words, we're going to do a verification process and also integrity process, right? Make sure this data is good. Make sure verify all the changes, or not verify, but make sure the changes are not harmful and negative. And make sure the data doesn't get deleted or corrupted in transit, okay, in flight. So when data is at rest, how do we protect data when stored? Well, the most bulletproof way is air gapping. Case in point, by the way, a way of air gapping is backup. Backup's a hot issue right now because ransomware is rampant. Well, it's not. I'd say it's starting to decline. It's in a dip right now, but it'll probably pop back up. Because we didn't really have a good solution for it. The solution for ransomware, a lot of times is access control, which we'll talk about. And again, ransomware is kind of a big issue with data at rest, right? That's data that's kept on a hard drive, it's in storage, and there's going to be some malware that's going to try to delete it or to encrypt it, and then when it deletes it, it moves it off site, which is why most people just prefer to encrypt it. And then they try to extort us for money to get that data back, right? So protecting this is right in the wheelhouse. Ransomware is right in the wheelhouse of protecting data at rest. So I'll probably reference it a couple times. But going back real quick to data backup became another. Ransomware really highlighted the need for good backups. And part of it is, we'll have real-time backups, which is great, and maybe hot swap or backup sites. In other words, data that's ready to go the moment our primary site goes down. That's great. That's lovely. But if it's online, it's also susceptible potentially to attacks as well. And it's always good to not only have that kind of real-time backup, but to also have a different media, some kind of backup tape, some receptacle data, external hard drive, something like that, that you store off-site, ideally, and is safe. In other words, it's air-gapped, right? In other words, there's no way to get to that data other than mounting it into a computer, right? So it helps protect that data. So that's kind of the concept of air gapping. Also, we can just simply, if we have a server that's full of valuable information, and we set it up so no one needs to access this server unless they're sitting at it physically, well, then why is it plugged into the network? It doesn't need to be plugged into the network. Don't plug it in the network, okay? So that's air gapping, just taking things offline. Access control is an important deal. The acronym here is AIM, ID, and access management, or just access control is what I like. Again, AAA, authenticate, authorize, and account for everything that people are doing. A big important concept in security. We're going to know who you are, we're going to tell you what you can do, and then we're going to write everything down, right? And that's the best way to have security, right? Because that process of knowing who you are and telling you what you can do is going to ensure preventative security, while accounting for everything you do is going to help us figure out what went wrong when something does go wrong. Okay, so access control is a big part of that, which is easier said than done, because a big part of that is, data classification. You have to figure out what's top secret, what employees absolutely need. The policy of least privilege, which actually should be in here. Policy of least privilege says you should only have access to what you need to do your job, right? So that's an important concept. And that when it comes to access control, so we need to classify data. We need to know what people are doing. We need to know who needs access to this data, who doesn't need access to this data, which can all be very tricky, because now you're getting into the world of business processes, right? And it's a very tricky subject, and a lot of managers don't like to limit their employees of what they can do, right? So it's going to be tough to have a manager say, well, only these 2 employees need access to that data. They're going to say, no, everyone needs access to that, because I would love for everyone to go in and do this, right? And that's nice, but if it's not necessary, it's not necessary, and we need to control that, okay? So let's talk about fault tolerance, and particularly RAID. Again, I've mentioned RAID before in the past, but we'll go over it one more time here. I think I had, yes, hard drives. So we got some hard drives here. I'm going to move these around, I think. Can I move them around, or I'm just going to draw a star on top of them? That's right. Maybe this, yes. So I'm going to move these around real quick. Okay, so let's do RAID 0. So RAID 0, right, what we're going to do is we're going to have 2 physical disks, okay? And what RAID does is it turns them into one logical disk, all right? We'll talk about the different configurations. With RAID, let's say, for example, by the way, RAID stands for a redundant array of individual disks. RAID 0. We'll start with RAID 0. RAID 0, what we're going to do, say our data here set is 21. This isn't exactly how it works, but it's a good simile. If our data here that we need to store is 21, we remember put a 2 here and a 1 here. What's that bias? Well, remember these connections back to the motherboard are slow. It's the 2-lane country road of data transfer, as compared to the bus or the RAM bus and going to the processor. This is a slow way to get information, is off storage. So what we're doing here is we're able to put part of the data on one drive, part of the data on the other drive, and because of that, we can read the data from these 2 country roads. We're sending a convoy down 2 different country roads instead of 1, so it gets there quicker, if that makes any sense. All right, so RAID 0, if we have a 1 gig drive here and a 1 gig drive here, because we're splitting up the data, we're not burning any we're not burning up any space, so this would make this a 2 gigabit drive. You don't lose any space. You lose a little bit. There's a little bit of overhead, but so minor that it doesn't really count. So we got 1 gig, so we got a 2 gig drive. It's going to look like a 2 gig drive to the operating system. This is going to look like one hard drive, but what we're actually doing is having 2 physical drives, and we split up the data amongst the 2 of them so that it reads the data faster. Gives us no redundancy, but things are fast, or at least faster. As compared to, let's backtrack a little bit here. Okay, as compared to RAID 1. All right. RAID 1, the way that works, or we call that mirroring. So RAID 0 is called striping. RAID 1 is called mirroring. And what we do there, if we have 21, right, we put 21 here, and we put 21 here. All right. It doesn't give us any speed, but what it does do is if we lose a drive, we still have all our data. Okay. Back at RAID 0, if we lost a drive, we lost half our information, and there's no way to recover that half. So we're gonna lose all the information. But in this case, if we lose a drive, we still have our information. We have redundancy. That's fantastic. Remember, this is a redundant array, so not all RAID gives you redundancy. Okay, RAID 0 gives you no redundancy. If you lose a drive, you're gonna lose the information. RAID 1, if you lose a drive, you still have your information. All right. The downside to that is if we have a 1 gigabyte drive here and a 1 gigabyte drive here, we're going to end up with a 1 gigabyte here, right? Because we're just repeating all the information. So if this takes 12 bits to store, we had to put 12 bits here, 12 bits here. Okay, so we're eating up the information on both drives. So you're going to lose half your storage with RAID 1. All right, but you get redundancy, which that way if you lose a hard drive, you don't lose your job. That's a good thing. All right, let's talk about RAID 5. And if we're going to do that, we're going to add another drive. So do I have an eraser here? I think I have an eraser. There it is. We'll erase this. Scribble, scribble. Wow, it's getting rid of the background. That's outrageous. How dare you? I didn't want that far. I guess I can't change that. Well, I rather have the line then, I think. Sorry about that. All right, let's go back to pencil now. And I'm going to include a third disk. Okay, so what we do at RAID 5 is we're going to take our data, 21, and through the power of math, we can store 2 here, a 1 here, ignore this line, and a 3 here. Okay, again, when we read information, in this case from these drives here, we're able to do it like we do with stripe. So we actually call RAID 5 striped with parity. Okay, and we're actually striping. We've got part of our data here, part of our data here. Fantastic, so I can read data off of there. Now the parity file is going to be as big as half the overall. So this is 12 bits. The parity file is going to be for 6 bits. Okay. But what that parity file buys us is if we lose a drive, I'm able to do a quick calculation. X plus 1. It's not this simple. But it is kind of relatively simple. X plus 1 equals 3. Oh, therefore X equals 2. Right, and now I can recover that data. I can rebuild this drive. I'm going to be down when I lose it, but I can rebuild it and get back up running. Okay, and because we're going to talk about in a second the reasons why we have other RAID systems as well, where we can keep up and running. Again, we store information here. So if these are all 1 gigabyte drives, what we're going to do is we're going to lose a third of the storage because we have to do the parity file. So we're going to end up with a 2 gig drive. So we have 3 physical disks. You have to use it 3 physical disks, and you're going to have a 2 gigabyte. It's going to look like a single 2 gigabyte drive to the operating system, even though you have 3 disks. All right. So that's RAID 5. Now, RAID. Let's get into RAID 1 plus 0. I think that's the one I have listed. Yeah, it's RAID 1 plus 0. So the best way to understand when you get these plus systems, and I'm going to grab the arrow here, and with 1 plus 0, I'm going to need another drive. I need at least 4. So I'm going to paste another one over here, and what we're going to do is organize them in pairs. All right, so the best way to understand when you have a plus system, so like 1 plus 0, the 0 comes after. So what we're going to have is a RAID 1 system, which is what this is, right? So we're going to put this under the auspices of a RAID 1, okay? And I'm not going to write that out again, so I'll just put 1 out over here too. So this is RAID 1. If we have data sent, right, we're going to do 21. We got 21 to send here, right? So we got to put a 2 here. And 21, it's RAID. I'm sorry, it's mirror, so it's 21, 21. Okay? Same thing over here, 21, we would do 21, 21, right? So we have that RAID 1 system. Okay, now 2 RAID 1 systems. What we do is we then put this all under one giant, geez, the line got crazy, RAID 0 system. So what's that look like? Well, what happens is, because this is RAID 0, I've got 2 mirrored copies. So what I do is if I have, again, 21 to store, right, I'm going to take that 21, and this is striped, so I'm going to put the 1 over here. So this is where it gets, so really, ideally, I'm going to do 2148, okay? So just to kind of understand what we're doing here, okay? So if I have a RAID 0, so I'm going to take this 48, I'm going to send it over to this drive, right? I'm going to sit there and say, okay, well, this is RAID 0, so I'm going to take half this data, I'm going to put it over here. This is RAID 1, so we'll put a 48 here. We'll put a 48 here, right? And we'll take this 21, and we're going to put a 21 here and a 21 here. That way I have backups. I can lose 2 drives in this situation and still be up and running, right? So I can lose half my drives and I can keep going. In this case, I got to put this in my head here. These are all 1 gigabyte drives. Now, since we got a RAID 1 system, right, this is essentially going to be just a 1 gigabyte drive. These are 1 gigabytes total. And then since we're RAID 0 here, we get these 2 here. We're going to take these 2 and they're going to accumulate. And so we would have a 2 gigabyte. The RAID plus 0 would be 2 gigabytes. All right. So the good news with this is I can lose. So I get my redundancy, right? I have 2 RAID 1 systems. And that all comes under a big house of RAID 0. So I get some speed, right? Because when I read this data, I can read part of the data from this drive and part of the data from this drive. I can use a couple those slow country dirt roads, right? I can use a couple of them at the same time. So that's RAID plus 1 plus 0. So remember, what you're doing with this plus is the plus comes after it's the overriding thing, the thing on top of it worked bottom up, right? So we have our RAID 1 and then a RAID 0 system over that, right? All right, so let's talk about RAID 5.0 and then 5.1, which again is going to be the same thing. So since we have RAID 5, right, what we're going to need here is 3 disks. So let's include get even more disks in here. And there we go. So a RAID 5 plus 5 plus 0 system is we're going to have 2 RAID 5 systems, right? Things are going to get complicated. And then what we're going to do is put them under one giant, we did 5 plus 1 first, I think. So we're going to put it all under one RAID 5 system. So this is all going to be RAID 5 plus. I said 1? We're doing 1 first? No, or do 0 first, sorry. 5 is 0. It doesn't really matter because we have 2, right? Because it's a 0. It's a striped system. So say we have 2148 again. We'll pick on 2148. If it's a RAID 0 system, I'm going to take part of the data, store it over here. Now this is a RAID 5 system, so what's it do? It takes a 21, puts 2 here, puts 1 here, and puts a 3 here. Over here, it's going to take. It says, "Oh, I'm a RAID 0 system. I'm going to stripe this." So I'll take the second half of the data. I'm going to put a 4 here. I'll put an 8 here. And a 12. I know 12 is bigger and it takes up 2. Space-wise, we're just going to say this all takes up, 12 bits and 12 bits. So 24 bits for the data set. So therefore, the parity file, even though it's a 12, would be 6 bits. All right. Point is, if all these are 1 gig, again, the same rules apply. 1 gig, 1 gig, 1 gig, 1 gig. But because this is RAID 5, it's going to be a 2 gig drive. Again, this would be a 2 gig drive as well. Since we're RAID 0, we get to combine these two. So even though we bought 6 gigs worth of hard drives, we're going to end up with 4 gig of storage. This is going to look like a single 4 gig drive to the operating system. And we can lose 1 disk here. All right, so if this disk goes down, this disk goes down, we're still good, we can operate. Well, actually, we're not going to be up and operating. We have to rebuild these disks in order to keep going. That's why RAID 5 plus 0 is built. So we have speed on top of speed, really. We have with a little bit of redundancy built in. If we lose a drive, it's not a big if we lose 2 drives, however, we're in serious trouble on one of these RAIDs because we're going to lose then half our data. There's no redundancy in striping. All right. That's why people like to run with RAID 5 plus 1. All right. Whoop. I lost all my drives. That's horrible. That's horrible. I think I got have redo. Okay. So let's just grab this and I can fix that quickly. All right. This is exciting television here. All right. There we go. There we go. All right, so let's do RAID 5 plus 1, right? So again, we got our 2 RAID 5 systems, RAID 5, right? And then we're all under one giant auspices of plus 1, right? So RAID 5 plus 1. There we go. RAID 5 plus 1. Okay, so what's going to happen is, again, if we have that data to store, we have that 2148 we keep picking on. I don't know why I picked it, but there it is. 2148, we're two RAID 5 systems. So what we're going to do is we're going to send 2148 to this RAID 5 system. So it's going to get 2148. It says, well, luckily I'm a parity system. So what I'll do is I'll take 21 here, 48 here, store 48 here, and then add them up, and I get 69, dude. There you go, 69. 21, that is an old reference. That's a Gen X reference. 21, 48, and then 69. Okay, so now we have our striping with parity on these two things, but we have complete duplicates of. Now the good thing about RAID 5 plus 1 is if I lose this drive, I can still operate. I can completely still operate. I don't have to do any downtime. This drive will turn orange. I can just pop it out and pop it back in. Okay. Now, storage-wise, I'm only going to get 2 gig. This entire setup, because we're copying the data from one over. Remember, we are going to lose a third here because we have our parity file. So we're going to go. We're going to get 1 gig, 1 gig, 1 gig. So that's only a 2 gig drive. And since we're completely copying the data over, that's only worth 2 gig too. So we're going to end up with a total of, even though we have 6 gigs of data here, we're only going to end up with 2 gig. But the good thing is if I lose a drive, I don't even have to go down. The server can stay up and running. This disk will just turn orange. I can pop it out, pop it back in. It can rebuild the data based off the parity file, and then when I'm back to RAID 5 plus 1. Okay, if I have a disk go down in both arrays at the same time, then the system has to go down, right? Because now I don't have that. I don't have access to that data. But that's what RAID 5 plus 1. Now, if you you might actually have RAID. There's all kinds of different systems. You can have RAID 50 plus 1. Anyway, if you look at a SAN system, you could have multiple disks go down. As a matter of fact, if you're operating a SAN system, often you'll see people with there's a stack of backup hard drives. Now remember, we've talked about this in Security 1, mean time between failure, especially these hard drives with the platters, stuff's moving. These things break, right? Solid state drives actually break as well, and there is a hot debate in the industry whether or not the mean time of failure is worse or better with solid state drives. Some people think they've actually gotten more reliable. They're still extremely expensive, and storage-wise, this is the way to go. Platters are still the way to go, bang for buck-wise, or at least megabyte per dollar wise. But anyway, or per penny at the rate they're going. But anyway, both hard drives are going to fail. Hard drives will fail, right? So that's why we have redundancy and we use a RAID system to keep that going. So some other important concepts: security is not the core business, right? We can't sit there and say, well, we went out of business, but damn it, we were secure, right? Usually core business is to process, money, process customers, and do their job, right? So understand risk, then avoid, accept, transfer, or mitigate. Have a realistic view of risk. Beware of bias. Again, the human mind is naturally biased, right? We're gonna. I mean, just look at how we assess. One of the things that drives me that I enjoy. Well, I don't enjoy it. It aggravates me is how much humans, particularly Americans, completely just ignore car risk, right? That driving 100 miles is inherently risky. Like highway travel is inherently risky. Moving in a giant vehicle going 80 miles an hour down a road is inherently risky, right? But it's just part of life. So some people are willing to travel on a highway every single day of their lives because they think that's less risky than, I don't know, living close to a city or something. It's a weird bias of risk, right? So we also have to be aware of that. We're worried about hackers. Well, no, we should be worried about inside threats as well, right? We can't trust all our employees all the time. Communication is a key part of success, is key to success. Make sure your stakeholders are kept informed. Repeat what you think your stakeholders want in your own words. Make sure there's no misunderstandings. These are all part of communication. So communication is key to success. All solutions are a variable combination of technology, people, and processes. There's no one size fits all. I talked about that earlier when we talked about architecture, right? So So what does the design look like? Well, there's going to be a research phase where we do information gathering, which it's when should research phase stop? It's never. There's no perfect answer, right? You have to be wary of analyzation, parallelization. In other words, you're spending so much time researching, you don't actually get the project started, which is but there's also such a thing as not doing all your research, right? So when do you hit that point? There's no magic button, right? There's no magic answer for that. When you get into the planning, testing, and assessing phase, you'll know whether or not you did all your research or not, and then whether or not you stopped too much, stopped too soon, right? But that's you're trying to do your research, try to cover all your bases. But you also be aware that you don't want to hold up the process because you're obsessed with researching, right? You don't need to know every little thing, although knowing most is usually a good idea, right? Someone else joined, by the way. Anonymous Skunk. Ooh. Anonymous Dumbo Octopus. All right, so plan. Start somewhere, all right? When you're planning out either doing a network design or architecture, start somewhere, right? If you have a blank page, get something down on that blank page and start building out on that. Don't worry about making mistakes in the beginning, right? Not everything you write down has to be perfect. Get something on the page and then build out from that, okay? When you are doing design, the question is, do you want to do middle out, outside in? Start from what you know. I know we're going to have a firewall. Put a firewall in the middle, right? Or put a firewall down and start building off of that, right? I know we're going to have 50 users, so let's put 50 users out on paper and figure out how we're going to get them to the internet, right? That's the type of thing I'm talking about, all right? Test, either simulated or in a lab environment, or imagination is possible. Again, testing is ideal. You want to do it in a lab environment or a simulated environment, not in the production environment. Production environments, things are up and running. This is the business trying to make money. Once you have it in production, if you find a mistake, it's much costlier and tougher to fix. So hopefully you tested it out in a lab or simulated environment. Simulated environment is a virtual environment. A lab environment would be you buy the hardware in a separate setup and you kind of just run it through and see if you can do it. This is true for like setting up servers or setting up a new system, setting up a new web server, which includes an entire back end of applications and databases it has to look up, all the way down to a complete network design, right? There has been network designs I have done where all the equipment was bought ahead of time and was up and running. Probably we had like 40 or 50 switches, a core switch, a couple routers, a firewall, all running in a separate room, simulating this in giant campuses network, right? That was like a lab environment, just to make sure everything works like we expect it to work before we start deploying it and putting it in the production environment. We're going to assess the test results, so learn what we can from these simulated or tested deployments. Adjust your plan and perhaps go all the way back to research. You might have to go all the way back to research here and say, oops, I didn't do all my research. Let me rethink about this, okay? I was going to tell a war story there, but I'm just going to move forward. Execute and repeat test, but in the production environment. So once you execute it, you're going to test again. Once you execute it, you put it in the production environment. This is where testing comes in again. This was not one of my strong suits. I'm not a detail monger. I'm terrible. I'm not really good with details. Luckily, I worked with people who were, and they were willing to go out and think of every possible scenario and try to execute things in the production environment to make sure it was working before the user showed up the next morning. Okay, so in summary, there's a difference between network architecture, framework, and design, right? Using network zones, one can create perimeters and defend in depth. We need to protect data in flight or transit, is what I like to say, and data at rest. We can use encryption, protected wiring, physical security, and to protect data in transit. We can use access controls, encryption again, because if we encrypt our data, even if it's at rest in a hard drive, someone gets access to it external to the operating system. By encrypting it, we make it harder to. We're protecting the confidentiality. Remember the big three things in security, right? Integrity, and confidentiality, and access. Those are the three things we need to protect in IT information security, right? Data classification, backups to protect data at rest. Know that every network architecture is built around an enterprise, which is built around its people and business processes. Therefore, it is normal for there to be no normal. Okay, this can be frustrating if you do it day in and day out. You try to follow basic frameworks, basic principles when you design network architecture. But no matter what you do, a hospital will not run like a financial institution, right? A educational institute will not run like a hospital, right? So you have to change. The rules are going to be different, especially if you jump disciplines of the enterprise. It's important to communicate your plans and to get buy-in from users and managers if you can. Communication's key. That's why we have you do things here at Stick, like presents, which is something I have to go work on right now, is getting a remote presentation working. So, all right. Well, I'm going to leave it at that. So this is lesson 2, topic 1, and I'll talk to you later. Bye.